August 6, 1945, an atomic bomb was detonated over the city of Hiroshima in Japan. Dropped from the U.S. aircraft the Enola Gay, the so-called little boy weapon signified the first use of nuclear bombs in warfare. Around 80,000 people were killed in the explosion, 70,000 injured, and 5 square miles of the once bustling city was destroyed, almost entirely leveled and burnt away by flames. 3 days later, August 9th, and the boxcar bomber dropped another nuclear weapon, this time called the Fat Man, over the city of Nagasaki, 190 miles southwest of Hiroshima. Statistics vary, but it's thought upwards of 40,000 people died, upwards of 60,000 were injured. Again, the city was ruined. The before and after aerial shots of Hiroshima and Nagasaki proved just how total and merciless the bombings were. Fast forward 3/4 of a century, though, and both cities are a far cry from the nuclear wastelands that many once predicted they'd forever be. Hiroshima is home to 1.2 million people. Nagasaki is smaller, but still has close to 500,000 residents. Both cities are key industrial centers for Japan, producing cars and tech products and shipping around the world. They're also major energy hubs, and in fact, some parts now run on nuclear power. The rebuild in itself is astonishing. But what's interesting is that there are no uniquely different safety concerns in either location. Those who live there today can do so without fear of things like radiation sickness or sudden cancer spikes. There are no exclusion zones in Hiroshima or Nagasaki. You can move freely without having to worry that you'll have, say, brushed up against something dangerous or inadvertently discovered a radiating remnant of the nuclear blasts of before. So how does that work? We know that it isn't the same at some other locations, such as in and around the abandoned city of Pripyat in Ukraine, notoriously left wholly inhospitable following the Chernobyl meltdown in 1986. But why is that a no-go zone while modern-day Hiroshima and Nagasaki thrive? Today, the bombed cities have been able to re-emerge mostly due to the physics of the attacks that they suffered. For Hiroshima, the actual detonation of the nuclear weapon was at a point 580 meters, almost 2,000 feet above the city itself. For Nagasaki, detonation happened at 500 meters above the ground, 1,650 feet. Both are then referred to as air bursts rather than ground bursts. The fireball that both produced generated temperatures that you'd otherwise find on the surface of the actual sun. And at that kind of heat, things do vaporize. Buildings and bodies literally disappear. However, as devastating as the Hiroshima and Nagasaki fireballs were, they both erupted at a significant distance above their targets, and neither touched the ground. And here's why both cities are now safe. The U.S. detonated at those altitudes, around a half a kilometer high, to maximize the immediate damage possible with Little Boy and Fat Man. In those two fateful moments, they wielded the power of a star. But as quick as it arrived, the energy began to siphon away. Fallout was carried, dispersed, and diluted in the atmosphere above, while neutron activation triggered by the blast was mostly too far away from the ground to turn everything else radioactive. Were you to have entered ground zero at Hiroshima or Nagasaki very shortly after either explosion, then there was certainly an increased risk of radiation, but estimates are that that risk will have dramatically lowered within only a couple of days. Even at the heart of the explosion, the long-term contamination levels weren't that significant, even though the initial blasts were easily the most powerful that humanity has ever inflicted on itself. Why then is Pripyat so different? Again, the physics of the event are key, plus the location on the ground. But there's also the sheer amount of nuclear material that the Chernobyl disaster was dealing in. To the untrained eye, a quietly smoldering nuclear reactor may well appear far less dangerous compared to the blinding light and mushroom cloud of an atomic weapon. But that's all part of the insidiousness of radiation. After the initial explosion in the No. 4 reactor core on April 26, 1986, the world's news outlets transmitted footage of the smoking Chernobyl site, along with maps covering the rest of Europe, at times the rest of the world, to track how far the fallout might spread. Infamously, the USSR tried its best to cover up the threat, but eventually, inevitably, a mass evacuation was ordered, and those who were moved out never returned. Today, the Chernobyl exclusion zone, otherwise known as the Zone of Alienation, stretches for around 1,000 square miles. The once busy city of Pripyat, the closest major settlement to that plant, stands abandoned and unchanged. Everything remains almost exactly as it was when it was originally left behind. Here, there's just too great of a risk of contamination to warrant doing anything else. The Chernobyl nuclear power plant is obviously on the ground, which is reason number one as to why the surrounding area is so much more radioactive today than Hiroshima and Nagasaki are. The fallout came into contact with so much more of the environment across this particular part of the surface of the Earth. More than that, though, the amount of fuel involved in what happened at Chernobyl is many, many times more than what was needed for the nuclear bombings. According to the Bulletin of the Atomic Scientists, there were 64 kilograms or 141 pounds of uranium in the Little Boy bomb over Hiroshima, and less than 1 kilogram of that underwent fission. In a widely cited and incredibly frightening statistic, it's been calculated that the Hiroshima blast was ultimately triggered out of just a little more than half a gram of matter. On the other hand, and according to the International Atomic Energy Agency, the Chernobyl explosion cast 400 times more radioactive material into Earth's atmosphere than the Hiroshima bomb did. Although really, and what's part of the enduring and sinister hold of Chernobyl, is that it's perhaps impossible to know for sure quite how much it really expelled. According to Soviet reports, there were almost 200 metric tons of nuclear fuel in Reactor 4 at the time of the meltdown and explosions. And so when the facility was quietly smoldering, it was more like a nuclear river that had just burst its banks, ruthlessly and relentlessly flooding all before it. The death toll for the Chernobyl disaster is notoriously difficult to know, the numbers allegedly skewed by Soviet data at the time. However, we do know that far more lives were immediately lost in Hiroshima and Nagasaki. With the detonation of those two weapons, the US changed the landscape of war and recalibrated the rules in terms of what humanity was capable of. There is no doubt that both categories of event are a tragedy of modern times: the instant searing chaos of a nuclear bombing and the slower, wider, immortal spread of a meltdown. Despairingly, there are cases in which the effects of both have more clearly overlapped, such as across multiple states in America, in and around Las Vegas and the Nevada test site, where a long series of on-the-ground nuclear weapons tests took place from the early 1950s until the early 1990s. The data is perhaps starkest across the Marshall Islands, however, where again the US has a long history of conducting nuclear tests. Studies show that some of the atolls are today 10 times more radioactive than even Chernobyl is. The sobering reality is that while most of the background radiation on Earth is naturally occurring, scientists do factor in a small amount of it as having been generated by nuclear weapons testing and by specific disasters such as Chernobyl. We can see then how events like the ones discussed in this video do have a global impact, as well as catastrophic local effects. But history shows that there are other things to consider as well. The two cities that have been bombed, Hiroshima and Nagasaki, have now recovered and rebuilt. Their history isn't forgotten,